let's take a look at simplifying radicals. The first thing that we need to make sure that we are understanding is what is a perfect square. Okay, a perfect square is when you can take a whole number and multiply it by itself, and the answer that you get is considered the perfect square. So for example, the square root of 1 is 1, because 1 times 1 is 1. 2 times 2 is 4, so the square root of 4 is equal to 2. 3 times 3 is 9, so the square root of 9 is equal to 3. So let's make our list of perfect squares as 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Now, of course, the list continues to go on, but for purposes of these questions, this is as far as we need to go. So what we need to remember when we're simplifying radicals is that when we're breaking up our radical, we need to make sure that we are using a number that is a perfect square when we're splitting it. So the process that we follow is that we take the number and we divide it by each of the perfect squares until we find the biggest one that works. So I'm just going to show you, even though some of them are a little more obvious that it doesn't work, just going to show you what happens when we continue taking 108 and dividing it by the perfect squares, going in decreasing order. And we do this because we don't want to make a mistake and not pick something that's big enough. So as you can see, 108 is divisible by 36. And so I'm going to put 36 and 3 under those radical signs. You want to put the one that is the perfect square first because it's going to help you make sure that you keep the numbers in the correct order. So now what we do is we take the square root of 36. So again, if you're not sure, use your calculator, but we know that the square root of 36 is 6. So I put a nice little line through it, not anything crazy so that you can still see what it is. And 6 radical 3 is our answer in simplest form. Now we can check our answer to see if the number that we got is actually equivalent. So I'm going to start with the square root of 108, and it's going to give us an irrational number. And now I'm going to take 6 square root of 3, and I get that same irrational number. Now, of course, if you choose a different number to simplify by, let's say that you chose 108 and you divided it by 9, you'll see that it works with 9 and 12. However, that would not be in simplest form. Even though 3 radical 12 would still give you that crazy same decimal, it's not completely in simplest form. So remember that the check at the end is just to see if your numbers are equivalent, but you want to make sure that what's underneath your radical cannot be simplified any further. Let's take a look at the second example. 112, and we need to figure out what to break it up into. So I'm going to start with 81, which does not work. 112 divided by 64. 112 divided by 49. 112 divided by 36. 112 divided by 25. 112 divided by 16. And there we go. It works with 16 and 7. So now we say, okay, which one of those is our perfect square? The square root of 16 is equal to 4 radical 7. Since radical 7 can't be simplified, I know that my answer is in simplest form, and I double check to make sure that both answers give me that same irrational decimal, and it does. The next example, the square root of 20. We're going to break that up into 2 perfect squares. Now remember, 10 times 2 does give you 20. However, the square root of 10 times the square root of 2 will not help you to simplify this radical. And remember, we've learned to simplify radicals to then apply it to the quadratic formula and completing the square. So we're going to take 4 and 5 when we do this, and then the square root of 4 is equal to 2. So my answer is 2 radical 5. So the square root of 20 and the 2 square root of 5 are equivalent. They are that same decimal. Last example, this has a number outside of the radical sign in front, so we just need to make sure that we keep up with that. The square root of 60 is going to be broken up into 4 and 15. Now again, 6 times 10, 3 times 20, those work. However, they're not perfect squares. So you can always make that list of numbers down the side of your paper, or you say, okay, well, 60 could be everything up until 49 that you can try and see what works. Don't forget to keep that 3 outside of there. Now the square root of 4 simplifies to give you a 2. So that is when we need to multiply with the number that's already there. So 3 times 2 is 6, radical 15. And radical 15 cannot be simplified any further. So we take our original, just to double check, and we take our answer, and there you have it. So always check in the calculator when you're finished. Just make sure that what's under the radical cannot be simplified any further.